When you start HyGCHP, you'll initially see an entry screen that contains several different configurations that you can run. You can run all of these configurations and compare energy use and economics between them. For now, we'll just go with the classic hybrid approach with a cooling tower. Click OK. You bring up the main screen. The screen's set up such that there are several entry tabs. You just need to click your way through these tabs, and the action really happens on the final design tab. In the first main screen, you'll see a schematic of the system that you're going to be analyzing. New users can click on this button here for a document that will bring you through these steps in more detail. For now, we'll move on. And at any point, you can also hit F1 while operating the software to bring up detailed online help that describes each input in each screen and how it operates. You're definitely going to want to remember that for details that I don't cover in this tutorial. The very first step is the loading of a building loads file. At the level of detail that this software works, it's really necessary that we consider the hourly loads of the building throughout the year, and not just the peak heating and peak cooling loads. Rather than attempting to replicate an hourly load calculation right within this software, which there are dozens of energy simulation softwares that do, you simply use the loads outputs from other softwares. One example, which I can show you very quickly, is eQuest. This is a very common building analysis tool. It's free from the Department of Energy. You can see here that on the Project tab in eQuest, you can set up hourly reports. Here I've set up 2 hourly reports, one that gives me the building cooling and heating load, one that gives me the outdoor wet bulb and outdoor dry bulb. I simply run the simulation with those reports checked, and you can go to File, Export Hourly Results. You will get those hourly results in a spreadsheet, which you can import directly into HyGCHP. Again, go to the help for a description about how to do that for various programs. And there's also a description of the exact format that loads need to be in. So you can take the outputs from any building loads calculator you might have and format them correctly. Also on the main screen, you'll find a few simulation controls for the amount of time to simulate and the time step. The amount of time will definitely affect how long it takes this program to calculate. A lot of people are doing ground source heat pump analysis and design in a time frame of 10 to 20 years. For now, we'll just leave it on 1 year. The next screen is the heat pump screen. This allows you to define the heat pumps that you're using. This software was designed assuming distributed heat pumps throughout a building, water-to-air units. You could use it for a centralized approach or water-to-water units. It's going to give you an approximation of the energy consumption of that type of system, but there's really no sophistication on the downstream side of a water-to-water unit in this case. The next tab would be the ground heat exchanger tab. This has all of the common inputs for ground heat exchanger design, geometry, and ground properties. One thing you'll notice that's not on this tab is the total size of the bore field. That, of course, is what we're trying to help determine with this software, so I'll get to that a little bit later. Next tab is the fluid loop tab. Here you can choose whether you want to do your analysis with water or some type of antifreeze solution, and also how you're going to go about calculating pump power in the analysis. There's a few different options depending on what suits your current status and design. The next tab you'll see is a supplemental tab. For this system, again, we were doing a hybrid approach with a closed-circuit cooling tower or a fluid cooler. Here you can choose whether there's a part load speed or not, and then there's a series of inputs, which I'm calling multipliers, that determine the performance of the equipment. To really see what these are all about, you'll want to go into the help, and you'll see it's a system using a series of curves to determine the performance of each of these pieces of equipment. That way you can set the cooling tower up to perform how the cooling towers you specify may perform. Finally, there's an economics tab in terms of inputs. This includes everything from global economic parameters to utility rates, all the way down to typical first costs for equipment. The key first costs, of course, being that of the ground heat exchanger and the supplemental devices that you'll want to determine different sizes for. If you want to, there's also an optional input for interior HVAC costs, which is the cost of equipment interior to the building, such as piping, valving, and so forth. That doesn't really change from design to design. You can also leave that to 0, and you'll still get good comparisons because those pieces of equipment don't really tend to change. And the last thing you need to do before you get results is come to the Design tab, and this is really where the action happens. First, we want to choose a run type. HyGCHP has 2 different capabilities. One is to run a single simulation. Let's do that right now. Simply go up to Calculate and click Run Single Simulation. It initializes and it'll run. This is a single simulation that uses inputs in terms of sizes of both the ground heat exchanger and the supplemental device, as well as control parameters. And you can use the schematic below to see what those control parameters are all about. It uses those inputs to run one simulation to determine what the energy consumption, operating temperatures, and total economic impact are for that design case. And you can change sizes, control set points, and determine what those outcomes are for other design cases. In this case, the key result being a 20-year life cycle cost, which is an excellent way of considering both the first cost and operating cost of your system. Note that there's also hourly results given, and those can be found in the directory shown at the top. Now, the software can also run an optimization. The optimization is essentially a series of simulations that are run using an optimization algorithm to determine which design parameters will result in the lowest lifecycle cost overall. You simply input some constraints and let it run. Because it needs to run many simulations to determine this, this can take quite a while, depending on the length of time of each simulation that you specify. So you may want to let this run in the background while you go do some other work. At any point, if you want to save your inputs for a given project, I suggest going to File, Save As, so that you don't save over any of the defaults that we've included with the program. Thanks a lot for downloading HyGCHP, and good luck with your hybrid project.